Okay. Alrighty. I think I'm going to start. Alright. Yeah. Boom. Oh, look at that. Oh, cool, that works. I think I'm gonna hide myself this time. I usually look at it. So I've been using, I said that works because the chat over here, maybe I should not minimize myself. The chat over here still works. I use this caffeinated stuff. Oh, am I leaking anything? Nope. I use this caffeinated stuff, Caster Labs caffeinated, for those overlays. They're okay. They only work with YouTube and Twitch, not my own cast, which is fine. But I'd like to work with Owncast. And then they do another weird thing with like alerts, like they're all separate widgets in OBS instead of just like one thing. So that's unfortunate. All right. Where's me? Is it just Twig White? Yeah. So just wanted to remind everyone, I know I have this on like every social media. Oh, I should make it on. Oh, I should do that. Let me do that actually up here. Log in. Let me make this post and then we can get started. I just wanted to remind everyone that I do have this open. If you are able to donate, you can. If you don't want to, that is completely fine. I was trying to think of goals. Actually, if anyone wanted to help me with a goal, I just put pizza. Originally, I put like increasing my server, increase my. Sorry, I logged in to do something on an application in 2024, and I'm bombarded with stuff that I didn't actually want to deal with. Okay, cool. I don't know why. It was the terms of service stuff. I don't know why they just didn't have me accept that in an email or something. I guess it makes sense because oh, that's not what I wanted. It doesn't make sense because if it was an email, everyone was just going to ignore it. Sorry, I thought I was on top of my stuff. Let me go here. Do that, I guess. And cool post. Interesting. That's not as sexy. It's not a link either. Anyway, we'll figure that out later. All right, let's see. So yeah, just ooh, let's get rid of all that. Oh, that was not what I wanted. I'm professional. Yeah, so just reminding everyone, I have this Ko-Fi, again, coffee, however you pronounce it. It's like Patreon, only it's better for the individual. Me, not necessarily, I guess maybe by extension, it'd be better with you, for you. But anyway, I don't know a good goal. So if you're watching this and you want, you have goal ideas, let me know. I have it currently to pizza because I just don't know what to do with it. I also used to have this as a server, like increase my server instance, I guess, for the VPS that I go through. But I didn't want, that basically only helped if you watched through my own cast website. If you watch anywhere else, it didn't really matter. So I don't know what to have here anyway. Do that if that tickles your fancy. If not, that is okay as well. I got a split keyboard, so if I sound better, that's because my microphone is closer to me, and hopefully we'll be hearing less keyboard noises because my keyboard is behind here and the microphone's like right here. So hopefully that'll be better for everyone. Better viewing experience. Let's see. So, geez, I need more monitor. All right, so we're gonna go through 1, 2, 3, 4, 5 commits here. It's kind of a roller coaster because as I did this, it was there's a lot of things that I realized I did wrong. I think the feature checking, if you guys remember, oh, that's different. Oh yeah, because I'm on a different thing. Yeah, okay, so at this point I didn't know. I think last time I didn't watch my old video, I probably should have, but I think last time I wasn't sure if we were learning, and I think I got it to where it would learn. It looks like it doesn't. Let me look at my commits and see. Code. We need a 1 model. Too good to be honest. Let's see. Oh, I think between epochs it's better. Back. Okay, well, I'm not going to get ahead of myself. We're just going to go through one by one. I know vaguely of, or I remember vaguely of what I did. But yeah, there was a lot of changes. Most notably, I went through a lot of different iterations, and I ended up doing the many to one. Oh, hello, Corey. How's it going? I miss you too. It has been quite some time. Oh yeah, I think I throw this away. No, I'm not. I'm home now. Back in, not doxing myself, but back in my place. The trip was good. I enjoyed the trip. Yeah, a lot of great food, a lot of sights to see. Ocean was really beautiful. I think I posted in one of the Discords some pictures if you wanted to see those. I can't remember which Discord, yeah, which 12 Discords I posted it to, but yeah. It was fun. I don't want to say China's cheap, but China's affordable. You can we ate out a lot and it was pretty cheap. Like we had big like noodle dishes with like meat for like 14 RMB, which is like $2, 2 USD. I might be exaggerating, but it might not have been that good. But yeah, like it was pretty crazy. We would eat, I think we ate seafood for around $7. Yeah, we went around to a couple parks. That was fun. We were on the beach a lot. Okay, so I'm gonna go through this code review. So this commit happened immediately after. Let's see, finished getting data, fix the learning rate issue. Fix the learning issue was using the wrong optimizer. Oh yeah, that's right. Oh yeah, that's right. Oh my gosh. Set up for another model. Testing data parsed. Fixed a bunch of errors there. Okay. Didn't stream this. Okay, I'm just gonna go through the stuff and remember what I did. Let's see, neural network. So I moved this over to here. I can't remember if I did that last stream or not. But yeah, what I added here is that we have this num layers thing. Got a new keyboard and my B key is not reliable, so I'm gonna have to fix that today. But it's super annoying. Anyway, not important. So num layers, and so num layers in the LSTM, this is just how many, how do I want to say? It's how many You can stack the LSTMs back to back to back. So it's how many layers of the LSTM. So they make it would be as if making multiple RNN LSTMs and just feeding them into each other, right? So instead of having to do that manually, you can just say like, oh, I want like this many layers, and it's like as if they make the same shape LSTM, and they all train they'll train correctly. So yeah, that's what the num layers is. So we still have that input of 4. So 4 features: the open, close, low, high, and then it outputs the the price of the open, low, close, high. Not necessarily in that order. It's a consistent order. I'm just saying it in a different order. And so then the hidden state. Let's see So it's the inputs and the hidden outputs, and then just whatever the hidden state is at the end is your output, essentially. So let's see, I did batch size before, but yeah, this now just needs to take in number of layers, because the hidden state will have needs to know how many layers it has for the weights. And then let's see. Whoops, that was wrong. Train. What are we going to? Going to 311. Is that correct? Yes. Because, oh yeah, we just give it the number of layers. So I've changed this since then, but like we just started with 3. And then yeah, epics. So not a huge change. I just wanted to get this layer stuff in because I thought, well, while I was on vacation, I didn't have a lot of time, so I just wanted to do something quick, and this was it. And then I found more time, and then I was able to do a lot more stuff. So we'll move on to the more stuffs, which is the important part, because how I calculated loss was incorrect. This next commit. Oh, this next commit. We'll see. We'll look at it real fast. Again, I didn't know how much time I had. Head. Okay. I'm gonna go back here. Go up top. So this one I just got rid of a bunch of stuff. Like I literally just like the old neural network, the non-recurrent neural network. I just had a lot of old classes and structures and concepts that I just removed. Yeah, I think that, I don't know if this runs right now. Okay, so yeah, that's fine. I'm probably not going to go through. Oh yeah, so this is what we're, we'll just go to the main. Start. Okay, yeah, so we're still doing all this stuff. So, right. So we parse all the bars. Oh yeah, that's the other thing. Hopefully, forgot to mention this, but I want to go through a lot of the code review stuff first, and then the other stuff that I want to do is I want to put these into dictionaries. So basically, each file CSV is going to be its own, is going to be the key, and the data that we have here, basically the supervised data and the min and max price, all of that's going to be in a class, and that's going to be a the value of the dictionary. So that's what I want to get to, but we'll worry about that in a little bit. So we're just going to go through some of this. Ooh, where did I put? Sorry, I have like on my other screen, I have the actual the diff on my git t instance. So I'm looking through that and making sense of it. Oh, did I have? Oh wait, did I get it? Oh, oops. Yep. Okay, I'm done. So yeah, the previous one was just getting rid of old stuff that I didn't need. Okay. So this one, oh yeah, I made a note, not streamed. So this one is the many to one model. This one's cool. This one's cool, and we did some structural changes too. So parse CSV, that stayed the same. So I got rid of the, where did I put that? I put that in time series. Yeah, I did. Okay, so this new one. So this is time series stuff. So this is all the data massaging stuff. I put that in here because we need it for, well, I needed it personally for different stuff. So I'm just showing you, we have different stuff in here, but I'm just showing you the RNN train stuff. The model check and the OANDA, like, is just my personal stuff. And so RNN train, neural network, and time series is just what we're showing you. Model check is me actually using it, trying to use it in the wild to see if it actually gives me anything that that is usable, and then OANDA is just to get the data. So here we put in the time series file, we just put all of the stuff that we're working with. I don't think I changed. Oh, I have a many to one function. Did I make that? Yeah, I must have. Cool. So yeah, this is so we have the supervised and then we have the many to one. So this is supervised 1-to-1, and this is just supervised many to one. So we can have a look back. Oh yeah, that was funny too. I think I caught that later. Basically I parameterized the look back to 2, but it didn't matter what I put in here because I just set it to 2 here. I think I had that just to test, and then I was like, oh, that should be a parameter. I'm gonna or an argument, whatever you want to call it. So I made it that, and then I never removed the hard-coded value from when I was testing. So it just never did a look back. It was just always 2. So that was fun, realizing that I messed that up. So that's more just a structural change. Let's go on to the next thing. I think this actually has some substance, some meat to it. It's a big issue with the many to one where it ignored the look back period and always set it to 2, which I just mentioned. Removed old code. We'll cover this on stream. Okay. I'm not going to cover this, but I will tell you that model check that I just showed you, that was broken, and I got it to work. Oh yeah. Okay, so yeah, this one's good. We're gonna talk about this. Oh, it truncated that. That's cool. Anyway, doesn't matter. So yeah, that immediately changed. Got rid of the look back, which was good. And then let's go to RNN train and see what's different here. That's model check, don't need that, not yet at least. RNN train. Oh yeah, so I did the standard, whoops, not that. So I wanted some consistency, so I did a seed for all of the random functions. So torch, Python's random, and then NumPy's random, are all on the industry standard 69 seed. This is just for testing. So if I compare one thing versus the other, it like actually changes and it's reproducible across computers, which I checked because I was on my laptop, obviously not on my desktop, that you all can see so clearly. Oh yeah, and then as a part of this, I realized that my, like I said, that my what am I trying to say? The tolerance checking was incorrect. So I like kind of gave up on the many to one stuff. So I had this look back. Oh, maybe I should have talked about that some more. Yeah, here we'll talk about that a little more. So yeah, we have this many to one. If you remember, that's just me giving the LSTM multiple instances of the time series. So instead of just giving it like t minus 5 and then it predicting t minus 4, and then me giving it t minus 4 and it predicting t minus 3, and then me giving it t minus 3 and it predicting t minus 2, and then 2, 1, 1, t. Right, instead of doing that, we give it t minus 1, or give it t minus 5 and t minus 4, and it predicts t minus 3. And then we give it t minus 4, t minus 3, and it tries to predict t minus 2. And then we give it t minus 3, t minus 2, and it tries to predict t minus 1. So that's what the many to one function does. So I kind of blew over that. And so I got distracted by the bug that I had, and I was excited to tell you about that, but you guys have no idea what this means. So supervise is what we did last time, right? We worked on that. We have input output, and it basically just gives it a supervised time series learning problem, where we have the linear data, and then we're like, okay, so like 0 is input, 1 is expected output, and then it breaks it off into like 1 is input now and 2 is the expected output, and it keeps doing that. So that's just massages the data, takes the linear time series array and splits it into 2 arrays that we can grade. Grade. And so this does the exact same thing, only a many to one. So the input is handled a little differently. So instead of just one input to one output, it is a variable amount of input to one output. And so we still have the linear, data, the time series data. Linear being, yeah, I guess linear is the right word, but just an array, a flat array of time series data. And then we're taking that into however many look back periods there are. So we'll have like 0, 1, like element 0, 1, and then we predict 2. So 0, 1 is going to go in input, and then 2 is going to go into output. And then we do 1, 2, and then in input, and then we put element 3 into output, so on and so forth. So this input isn't fancy or anything. I don't think. It's just, yeah, so we just did math here basically, and I'll go over the other thing we did. But yeah, basically this is just a slightly bigger array. So we calculate exactly how the input should have been up here. We calculate how big that should have been, and then we multiply it by the look back, because we want that many extra inputs, because it's storing that many extra inputs, right? So for 2, if we have data is 10, right? We want this to be 10 minus 2 is 8, and then 8 times 8, 64. So this is going to be 64 because we're going to fill it up. I don't know if that's correct. Doesn't really matter though, because I gave up on many to 1. No, 8 times 8. 8 times 2, 16. Yeah, there we go. That makes more sense. So yeah, so if data is 10, if length of data is 10, and our lookback is 2, then 10 minus 2 is going to be 8, and then 8 times 2 is 16. And so we're going to be storing 16 numbers, which is 2 numbers for each data input that we have, right? Or for each expected output that we have, which makes sense because then our output is going to be 10 minus the look back period 2, and that's going to sorry, I'm mystified about this array stuff. I remember looking this up because I think you can, in Python, I think you can assign, oh yeah, basically, okay, so I'm basically here in Python, I'm saying this range in the array, assign it to this range. So this would be, if anyone comes from the C world, this would be like a mem copy, basically. So you have some data, an array, and then instead of just copying the whole thing, you're like, oh, I want like element like 2 and 5, like 2 through 5 to be copied into like this buffer. And like you might be like reordering the buffer or something like that, right? So this is a way to do that without having to think of the memcopy function. I don't know if Python has a memcopy function, probably not. Just use this. But yeah, so essentially what we're saying is like starting at the any, starting at the any and then ending at any plus look back, right? Because that's going to be, so when we first come into that, it's going to be 0 to 2 in the example of 10 with a look back of 2, right? And then so that's going to go from 0 to 2, and then we're going to say, hey, do I, we're going to start to, it's going to start at 2 minus the look back, which is 0. So data from 0 to I, which is 2. So it's going to give us 2 elements in the array, right? And so it's going to assign this looks really dumb on the 0th iteration, but it makes sense on this on the next iteration. So we come in here and we say ini plus loopback. So ini is now 2, and then I is now 1. And then so we go here, and so we just wrote 0 to 2 non-inclusive. So it was like 0 and 1. Oh, this might be size. This might not be range. I forget. Anyway. So we go from 2 to 4 now. Okay, that answered my question. It is a non-inclusive element. So we go from 2, including 2, then you go to 4, not including 4. So there's only 2 elements that need to be filled up between 2 and 4, which is 2 and 3. And so then we go over data. Now I is 1 now. So 1 minus 2 is 1. And then we go 1. Wait, what? What did I say? Is this right? This might not be right. I is 0. Oh, no. No. Oh, okay. So I is 3. Because we started, so it's a range between look back, which is 2, and length, which is 10. So we started 2, so this was 2 minus 2, 0, up to 2. And so now it's 3 minus look back, which is 2. So 3 minus 2 is 1, and then 1 all the way to 3, non-inclusive. Right, so we've slid 1 in our data, which gives us fills out the next input. Sorry, that's really hard to explain. But yeah, so that's how we do that part. I'm going to scuttle through that because my brain hurts and I don't know exactly how to do that, or exactly how to explain it better, I guess. So I hope staring at the code and me struggling through that was valuable. Oh, whoa. Oh, that's right. Okay. So I gave train RNN a sequence length, right? And yeah, okay, so our input just changed, right? So I was able to get the batch, I believe like before. Indexer. Oh, no. Well, yeah, similar. So like if this was a 1-to-1, this is just 1, so none of this changes. But since this is 2, it doubles the size of the batch so we can fit twice as much data in it. So now we just do the correct things over here, which is very similar to the many-to-one data prep that I was talking about. So we take the batch iteration times the indexer. I don't know why I called this an indexer. It sounded good at the time. It's not a great name, but it's basically just the batch size times the sequence length. So in this case, it's going to be 10 times 2 for the many-to-one problem, or whatever you chose. So it'd be 20. So here we grab right, like it's just offset, right? So it's like, this is very common when you have a linear array and then you want to grab chunks of it, like this how you do it. And then the important part is that we view it differently, is that we do sequence length, which is how many t's, how many time periods there are, and then batch size, and then the output. So this is 2, 10, 4. So we didn't need to change this too much, and I don't think I've actually changed this, even though I've moved away from the many-to-one. I might revisit that later, but we actually didn't change this too much. So yeah, that's the stuff I did to support many-to-one. I had 1-to-1 and many-to-one to compare the two. Let's see, what else did we do? I think that's it here. Okay, so then I guess the whole big what I actually wanted to talk about is just in this one. Okay, I'll read it down here, I guess, because I haven't streamed this. Made a lot of changes in the model check. I think it is doing the correct things. Able to unprocess the data. Made the end-to-end train. Also unprocessed data during test. This needed to be done because the check feature correctness was incorrect, because the prediction was between -1 and 1. If the expected was negative, then we would okay, jeez, dev-eyed by a negative number, and that is going to be less than the tolerance, which is not correct. also fixed inverse difference, as that was wrong too. Inverse difference. Oh, okay, yeah. Made sure all the data was correct both ways. And in the check, put a lot of functions in common places. This model is way better than the old one. This one is really accurate comparatively, 0.5% tolerance, guess correctly about 98% of the time. But being 0% is kind of useless. Yeah, so that was the other thing, is that like I got this very, very good. So if you remember, I think we got feature correctness. What was it? It was like 15, it was within 15% of the all features, and then we got that like 70% of the time. Now it's 0.5% tolerant, like feature correctness, 98% of the time. So that was really good. But yeah, let's go through some of the code. Let's see, model check, we don't go through. Neural network, check feature correctness. Here we go. Neural network. I don't know why I put that in here, but past me decided it was good. Did I do anything with this? I think this is fine. Yeah, so we didn't actually explicitly do anything with that. What we did is that the predicted and the expected are now scaled back to actual real world values. So I'm gonna blind you. So this LSTM uses the TAHN, TAHN. Whatever. So the LSTM works best with negative 1-to-1 numbers, and because the because I do a less than here. So okay, we'll just go through. So we come in with a predicted value of negative 1-to-1 and an expected value from negative 1-to-1, and so we subtract the two and then do an absolute value, right? And so that's fine, you got rid of negatives. But then we divide by not the absolute value of expected, right? Which I guess I could just do anyway. Which gave us a negative again. So if expected had a negative value in it, then it would change our diff to a negative value. And then when we did the less than, then obviously a negative percentage is going to be less than a positive percentage all the time. So it could be like negative, like, right, like it could be like negative like 50 of our tolerance, which is supposed to be incorrect. It's supposed to be 50%, like 50% incorrect, but it's never going to be picked up. So that's why it looked really, really good. So yeah, we never actually changed this function. What we did, or what I did, is yeah, when we test RNN, let me go back to that. Oh, so obviously the test also has the sequence things, but I gave it the min price and the max price, and we use that and our scaling functions to unscale the data. So we unscale both the predicted and expected data. So here we inverse the scale, and then we inverse the difference, and so we also get the original what is this? We get the diff, I think. No. So when we unscale, when we inverse the scale, we get the diff. And so this is just pure raw bars. This is the pure unfiltered bars. And so we inverse the difference because we have diff and we want the previous value, basically whatever we subtracted, because we'll take element 0 minus element 1 and then element 1 minus element 2, and right, and so those become the diffs. So we want to take our diff, add it to element 1 to get element 0, take our diff, take diff 0, add it to element 1 to get element 0, and then we want to take diff 1, add it to element 1 or 2 to get element 1. So that's what we do here. That's what I fixed. I remember, whoops, I mentioned that this was incorrect. I think this was a little off before. I can't remember, did I fix that here or in a different check-in? This is also surreal going through, because like this is not a lot of code, and I was like remembering the code that I had written and like all of the work that I've done, and like waiting for the training to happen, and like all of this stuff, and like the days, because obviously I was on vacation, so I could only, like, some nights were only like very little time spent on very little free time. So it just felt like I did a lot more work, like a lot more stuff. I thought I would be able to show a lot more, things that I've done, but like I think most of it has just been kind of playing with values and kind of coming to a conclusion, which is kind of very scientific, which I enjoyed. But it was like running it and then, oh, that didn't work. Let me go and check why that didn't work, or eventually coming upon the check feature correctness and why that was incorrect and broken. Kind of surreal thinking about it. But yeah, so I fixed the inverse difference. I think that was slightly off. And so here we take the predicted values, we get the difference, and then we shove that into here and we inverse the difference, and so we get the predicted what am I trying to say? Get what the value should be here. And so expected is the same thing, only expected. And so now that gives us positive values for both. And these are 4x numbers. So I mean, like stocks, it would just be a positive value, right? Like 0 to whatever. Zero to 1,000 or whatever. Whatever your stock trades at. But for 4x, it's like 1.01387620. Or I guess if you're trading USD and Japanese yen, then it's like 145.056120 something. So yeah, the important part is that they're whole number, they're positive numbers now, and so then the check feature correctness works correctly, and that was a big breakthrough. So this ended up not being that good. This ended up at this point oh no, sorry, it did end up being good. So yeah, like I said, that, oh shoot, can you guys see this? Yeah, kind of. That's a crappy spot. Let me just move that over. Can I do administrative tasks? No. Okay, that's fine, whatever. Just ignore the ad. Blah. Yeah, sure, that's a little better. All right, so with LSTM, batch size of 10, hidden is 5, epochs 10, learning rate, that number. Our tolerance is 0.5%. We were at 98.4, which is pretty good. So yeah, this is just me testing everything. We're not going to go over all the numbers. But here, if I make it, what is this, 0.1 now? Yeah, if I make it 0.1%, which still probably isn't that useful because markets don't move that much in a day. So then we get something lower, and then I tested this last night. First, I was able to recreate this, which is why we seeded to the industry standard of 69. And I was able to recreate this number, and then yeah, that was the only bad thing about me is I don't version control my data, so I wasn't sure exactly what all of this was, but yeah, I'm pretty sure it was hour 1 on euro dollar from, I don't know if it was 2000 or 2004 or something for training. I'm pretty sure testing was that number though. I'll read that out loud. 2021 January 1st to 2023 December 31st was test data, and then training data 2000 January 1st to 2020 December 31st. And so this was me just playing with different things. Yeah, so I'm pretty sure it was the same data, or very similar data, because I got the same result. It was like this exact same number. So I'm pretty confident in that. And then this was me playing around with it last night. I was just changing literally the same data. I didn't make any changes. I just made different, so epoch, I made different hidden level layers. That seemed to improve things quite a bit. But yeah, let's see. Is that all for code review? I feel like I did not do a good job explaining that. Check feature correctness. Cleaned up some stuffs. And price, max price. Time series. Oh, what's that? Oh, inverse difference. Oh, cool. Yeah, here, let me, I did change that, the inverse difference. Okay, so I did change that in this commit. Let me copy. Don't copy that floppy. Oh, put that down. Dang it. Put that down. Okay. Okay, so this is what we had. I think this took me a very, very long time to like conceptualize. I don't know if I should even explain it, because I think it took me so long to like mentally think about what this was doing and why. That's probably what took me so long, is because I was debugging a lot of why I thought I did a lot of work, but I don't have a lot of code for it, is because I would think I was just verifying that all of these functions worked multiple times with multiple different data. Like I checked everything multiple times. So I'm a lot more confident in what these are doing now. Let's see. I don't know why that was important. Yeah, I know it was getting the wrong value, obviously. Let's see, let me bring up that spreadsheet once more. And then, so yeah, many to one data was wrong. yeah, so I think this was me double checking the diffing function to make sure that was correct. And then I had a lot more over here of just like double checking and making sure I can go from one to the other and come back, and all that stuff. And I think I ended up verifying that like it wasn't grabbing the correct elements, because I was doing batches of 10. Oh, I guess I only got 8 here, but I was doing batches of 10 to verify all this data. I don't know why. I cannot explain to you why the negative interval needed to be added. I just know it was not the correct wasn't getting the correct data when we were inversing the diff. Like I said, instead of giving us, what did I say? Instead of giving us like yeah, because when we calculated the diff, when we unscaled the data, it gave us the diff, and then we wanted to, like, for diff 0, we wanted to, in raw data, we wanted to add it to like data element 1, so we can get data element 0, and then right, and so that's the process of unscaling the data. And I think it just gave us, the wrong number. Like, I think maybe like the first iteration was fine because like interval was 1, and so like it didn't like matter, but like as you went on, like it would start messing up. It would start giving you the incorrect element. So you'd want your diff plus element 1, diff 0 plus element 1 of data, diff 2 plus element or diff 1 from plus element 2 of data, diff 2 plus element 3 of data to give you 2. It would just start giving you like in the incorrect number. I forgot the math behind it all. Yeah, so that was what I came up with. Let's see, is this just, are we head now? Head is detached. How do I not detach? I'm gonna Google real quick. Reattach head, yeah. Keep your changes associated. Oh. Get check. Whoops. What game was I playing? Check out LSTM. Right, that's what branch we're on. Cool. All right. Python and then train. I think this takes 2 minutes, maybe. I need to take a break and get some water. I'll let this run. Probably mute my mic. I'm going to take a short break, and when we come back, I'm going to do the one thing that I talked about, where when we parse this into bars, which I guess we don't have bars anymore. But when I parse the CSV, I'm going to put each file into a dictionary, and that way we can separate, basically keep each data contained. Because now that we do all this data processing and massaging, we don't, it will drastically change everything. Like, there will be no meaning to each individual currency pair, or if you wanted to use this for stock, each individual stock. It will just change too much. So well, maybe stock might be okay. Anyway, doesn't matter. For currency pairs, it matters. So we're going to keep them independent of each other, and we're just going to process through each one differently, which might take forever. So yeah, it will effectively like multiply like 7 times our data, which might be good. It might give us a really good accuracy, or it might fuck everything up. I have no idea. Anyway, this is about halfway done. Oh shit, I hope this is halfway done. What is this? 10, 5, yep. This is about halfway done. But yeah, I'm gonna go take a break, stand up for a little bit, stretch my legs. I'll come back in like 5 minutes. Yeah. See you guys in a little bit. I'm back, rejuvenated. My music stopped. It's okay. We'll get some new music. What do we want? EDM. Let's try ambient. Sure. Okay, ambient. That's fine. Oh yeah, it took a little longer than what I thought. I thought it was 2 minutes. That like 4. Well, that's fine. Let's check the correctness. 737-406. Boom. Perfect. So this was taken on my laptop early last month. These I did last night on my desktop. But yeah, I just wanted to verify that these were correct or reproducible at the very least, and they are. And then yeah, so the big motivator for all this is that 1, this looks better. 2, I want to verify. So this is our data. So we have about, let's see, train. What is that? We have almost 7 megabytes of data. Those files look like train, like this. So it's just timestamp, and then price 1, price 2, price 3, price 4, and then that might be incorrect. Volume. I don't use volume. I was hoping I could use volume, but it looks like it's. Oh, okay, that's weird. I wonder if they just didn't track it, or if it was tracked differently, or if there was like literally for the 4 years of operation, like no one traded on this platform. Anyway, so that's what the data looks like, and we have about 7 megabytes of it. So if we increase that by like 7 times, maybe we will get more accurate. So that's the theory. And then another reason why I kind of think that's true. Oh, that's 30 epochs. Yeah, let me do 10. Okay, 88. Yeah, so we did. So this is M15 time. So you literally just get. It might be. I can't remember. I did a terrible job of like writing a note of what time period this actually is and how many megabytes of data I had, but like this is 15-minute time period. So if you're not familiar with like stocks and trading, every candlestick is the time period, and you can view whatever time period you want. So you can see daily, so it'd be the daily open, high, low, and close, whatever it closed at, either above or below the open. Or you can look at like hourly, or 15 minutes. And you can even go down to like ticks, or like 1 minute and 5 minutes. Anyway, what I'm getting at is that if it's the same time period that we're looking at, M15 has 4 times more candlesticks. I guess data. In our case, data. So the reason why I was like, oh, more data, maybe it will make it better, is because I grabbed M15 of the euro dollar, and it seemed to be more accurate, but I need to test that with different types of data, because this is obviously just the euro, so it'd be interesting to see different currency pairs. So that's the motivation behind me kind of wanting to do this next part. Also, I might might jinx myself here, but I don't think it's going to be too hard. Let's just get going. Ooh, I should not have. Oh, that's right. I stuffed everything into. I think I stuffed everything into a thing. 1, 2, 3, 4, 5, 6, 7. Yeah, so we're gonna get like 6 times the data just by doing this. Yeah, I really need to fix this key. New keyboard, the B key is the only thing that's like not consistent. It happens twice or it like doesn't happen at all, so I don't know if it's bent. Most of the other keys seem fine. Do we want different time periods? No, fuck it. This might take a while. I should have been smart and had it not get Euro again. Look at all that data. Cool. And the data works both ways, so that's important too. What I mean by that is we get twice the train and twice the test. So hopefully we make a more robust model. Python have maps? Are they called maps? Are they called the? Oh, it is a map. Nope, not the map that I was thinking of. Shit. Okay. So I think I need class. What do I want to call this? Whew. Any ideas? What okay, so what are we doing? We're taking a CSV file, we're gonna parse it into our bars, our scaling data, and then our supervised learning data. Bar data. Excellent. Look at that. What's this gonna have? What did I just say? Bars. That's one of those. Then we're gonna have min p, max p. And then our supervised learning. Supervised. They need to be like that, right? Like so. Is that fine? Right? Am I doing this right? Neural. Oh. Should I just define everything in there? Am I gonna have everything? Bars and I might not. Oh shit! Wrong button. New keyboard. Who dis? Bar. This is half the reason why I put everything into this def main function. I used to have everything just in the raw Python script file. And then I put everything in the main and then added this if name main stuff specifically so I could just return early and just test stuff and not like run through a whole training thing. Wait, what? Oh. Okay. Cool. I don't know why. I guess I don't need this anymore. Sure. I don't think I need I. Oh, I do need I. Oh, I'm not gonna have any of that. Oof, duh. Do I just start with bars? Maybe I should end for today. Maybe. This is what I get because I said, oh, I think this will be easy or pretty straightforward because I had a clear idea in my head. But now that I'm going to type it, it's a bit fuzzy and it probably doesn't help that I'm jet lagged. Well, here, I'll talk through it to people and then I'll probably end for today and then that'll be that. So what I'll do next time is I think I'm going to put these just into the class itself. Not that it matters because it's Python and nothing's real. And then when we parse CSV into bars, we will make bar data. We'll take the file name. Yeah, we'll take the, so at the end of here, right here, we're gonna, yeah, no, we do need to do it in here. Okay, so I might pass in like the directory that it should go in, and we'll separate. We'll have two different dictionaries. Directory, I said directory, I meant dictionary. We'll have two different dictionaries, one for training and one for testing. And we'll take that as an argument in here. And here we will stuff the stuff in here. Okay, so add a dictionary entry. And we'll use the file name, the variable file name, as the key, and we will make a bar data which will just contain bars for now, and then as we massage the data we will fill out min p, max p, and supervised. Okay, so add dictionary. Dictionary file name is key. Make a new bar data to store bars. And then we're going to keep bars up here. The reason why we have two is because we need to keep, whoops, I don't want visual. We want to keep bars as it was parsed so we can undo or inverse the diffing, inverse the difference. So that's why we keep that here. And then these two are going to be pulled out, or these three are going to be pulled out. And I'll fill that out later. So we're going to parse CSV into bars. We're not going to return anything, I don't think, and we're just going to add the dictionary in here, which I guess maybe we don't have an init function, right? And we just have bar data raw, and then instead of assigning this variable, structure. Just us, the structure. Okie dokie. So yeah, we're probably not going to return anything. We're just going to have a dictionary, and we're going to expect it to just populate it with all of the files, or all of the CSV files in here. And yeah, we're probably going to make a bar data, or yeah, I'm going to make a bar data once we're in here. Once this pass in here, and we have contents, I guess, I'm going to make bar data entry with file name. And then it's gonna have bar data, and then we're gonna set this, we're gonna set that entry's bars to this, and then populate that. And then it doesn't have to return anything. And then we're gonna go down to main. And then, so instead of train bars, we're gonna have like train dictionary and then test dictionary. And we're going to pass that in to here, right? And then after that, I think we're going to come over here, and I might make a function to go over each key or each element in the dictionary and massage the data for each one independently of each other, right? Because because that's the whole point. So each key is going to do this stuff. So we'll do it 7 times essentially, and then for training, and then 7 times again for testing. And that should be fine. And then I think when we come down here, this might get a little, I don't know. We'll have to monitor how this works. We might have to make new train and test RNNs. But what I'm thinking is we do these separately. So we would, for each entry, for each dictionary entry, we would go over the data. So we would not change the train and test functions at all. We would keep them the same, and we just change the data in there. So instead of train supervised, it would be like, for each key, it would be the bar data that's supervised. And then for test, we do test data, and then the min price, max price, and then test bars. Yeah. Wait, does train goes back, right? Wait, why does, I thought train goes backwards, right? Does it not? No. Interesting. I wonder. That might be something to look into. I don't know if that matters or not, but essentially we're doing all the loss function and like the optimization, backwards gradient, and all that stuff based off of the massage values. I even have a to-do to like unscale these to see if that changes at all. I don't know why it would or wouldn't, but it's an unknown variable that I'm unsure of. But yeah, okay, so that's about it. So that's what I'm planning on doing later. I'll try to do that on stream, probably tomorrow, hopefully tomorrow, depending how I'm feeling. But yeah, the goals for tomorrow are going to be finish stuffing this, which I think we have a good outline for. And then right, so those will be correct, and then we will write some code to handle this for multiple data sets, data sets, both the train and the test. And then in the loop, we will iterate through those multiple data sets. So yeah, it shouldn't be too bad. I'm just very tired. I can't think clearly. So I'm gonna end it here. I'm glad we got caught up on everything that I did over vacation. Again, it's kind of surreal thinking about and going through and talking about all of that, because it feels like I did a lot more work. But a lot of that was kind of just verifying the data, or like being scientific and like running a process and like, okay, well that did or didn't turn out how I wanted it to. Like, what can I change? How far does this lever go before it just doesn't do anything anymore, right? Which was very fun for me, but probably not streamy. So it's probably fortunate. But yeah, I was really excited to come back and like tell everyone about it, but it just appears that actually wasn't that much code, and a lot of it was just one-liner mistakes as per usual. Next stream, see if we can get multiple files parsed, and that will increase our data by a lot. I might have to run that off stream. That might get boring. Maybe I'll pull smaller data just so we can do something on stream. But anyway, I think I might lay down for a little bit because I'm tired. I'm gonna try not to sleep though, because that's gonna mess up my sleep schedule. But thank you for tuning in. I will see you guys next time. Bye.